Well, thank you very much for your time, and Jim. It's very nice to meet you today, Jim. Jack Johnson, I'm the CEO and one of the co-founders of Volta Power Systems. And this, I'm sharing with you the summary of our scale-up story and our focus on advanced energy systems for underserved markets. So the challenge with advanced energy technology is when you look at what is involved, a lot of people just say lithium ion. But these systems are very complex, they're very capital intensive. There's a significant amount of IP and limited knowledge base to be able to execute what you see today in the news in advanced energy solutions. Generally results in a very high cost of entry to access this technology, which leaves out a lot of the smaller niche markets that we've traditionally seen that supports much of the infrastructure in the automotive industry. And the challenge really comes around this simple diagram. A lot of people want to hear, when they hear the word battery, they associate with technologies they've known for the last 80 to 100 years, right? It's in our genome. We understand what the lexicon of a battery. We think they're these docile things that you can put and pull out of a drawer and make them usable. But the reality is the technology for advanced energy systems are really designed to replace engines. And when you inherently, most people understand that an engine is quite complex, and there's an engine for every application. Every vehicle is unique, and they all have positive and minuses in terms of their performance. And that's really what we're talking about in today's modern advanced energy solutions. They're really designed to replace engines, and with that creates a lot of challenges for smaller markets to participate in this change that's happening in the industry. Our focus here is three basic markets. We work in the RV, marine, and special heavy equipment markets. And what you'll see very quickly is you add them all up, it's a $165 billion opportunity, market share out there. But the challenge is they're highly segmented. Unlike what you'd see in the automotive world, names you recognize, General Motors, Ford, Honda, Toyota, Tesla, where you've got a large amount of volume centralized around one OEM. The amount of OEMs globally are many, and that creates a challenge to get scale in these markets. So it creates this segmented system that people can't really have the access to dollars to develop or utilize advanced energy technology. On top of that, the drive cycle is totally different. You know, the focus today in today's economy is, hey, we want to electrify transportation. Well, they're really focused on one application, and that's transportation from destination A to B. Well, all of the vehicles here and all the that we're talking about here are either, they're either designed to move to destination B and then do work all day, or they're designed to be something like a getaway, or you're going to go use it to camp, or you're going to go use it to enjoy a day for leisure. But it's not about getting the destination that matters, it's what happens at the destination that matters. And so we've come up with a way that we can provide automotive level technology and systems and a scalable solution to address these markets. So we offer complete energy solutions capable of replacing generators completely, or we can hybridize about any chassis. And that's a big thing because often the scale and investment to hybridize a program, there isn't enough volume to justify the investment. And we can do this on simple platforms that offer customers the ability to flex to whatever they need in a small application. We build everything here in Holland, Michigan. We're partnered with a major automotive OEM, tier 1 OEM that produces the lithium ion cells. And we build them into full, complete kits. You see here the picture of a pack. We have several different packs we build, ranging from 3 kilowatt hours, and we can build up to over 100 kilowatt hours. Everything is done at low voltage, so we don't have any of the liability or post-sale costs that come with high voltage applications. We have designed built our own line of high performance 58 volt alternators that gives us a high power capability. And then we have distribution capabilities to provide the customer whatever voltage they need, 120 volts, 240 volts. If it's a 3-phase industrial, we can flex our solutions to meet that small customer application without them having to spend the tens of millions, if not hundreds of million dollars in development required to deploy modern advanced energy technology. And this all results in Volta being the only automotive supply chain focused company providing advanced energy in these into these markets. And over traditional lithium ion that's out there today, our systems offer twice the energy storage for the same space and weight. So we're half the weight, half the space. And then with our power ranges, where everybody else is limited at 12 volts, we're at a higher voltage, offering 5 times charging capability over all the other applications that these markets currently are confined within. For an example how this works, I've got a sample A and a sample B analysis here. On the left is a specialized electrified lift truck. This would be seen working on power lines or industrial lines. They're often used by your local municipalities. The truck on the left, specialized just to electrify that system and to drive the wheels. It's an $80,000 plus application. With our systems, we can do the same work, same capabilities, basically give you 90% of the value points that a full electrified unit would provide you, but at less than a quarter of the cost. So we are able to get to that significant emission reduction. We're doubling engine life, so we're creating value for the consumer. We don't require any special infrastructure, no special charging capabilities, no major investments for these fleet companies, and overall at a quarter cost of a traditional EV solution. So significant value proposition over the path a lot of systems are going after right now, going full electrification. We're also on RVs. To give you an example of one of our best-selling systems, the #1 selling Class B RV in the United States is the Winnebago Travato. We electrify that whole vehicle now, completely eliminated the need of a generator on these RVs. It's been very successful. I think 65% or 70% of the units have been sold go to California, as the consumers there recognize the value of emissions-free, no nonsense, no hassle solutions, so that when they go camping, they can go anywhere they want off grid without the concerns and challenges with a generator. You can see these are just an example of all the products we provide. We provide complete kits so that the customer purchases it much similar to they would buy a generator, right? You buy a generator, we have a word for it, comes in the box, they can hook it up. Our solutions are very similar. Yes, they're distributed, but it's a package that minimizes the investment or the ownership that the client, in this case Winnebago, has to invest. We manage all that for them. A little bit about background, how we made all this possible. I was with Johnson Controls for over 16 years, and we were part of the big recovery activity where billions of dollars were poured into trying to develop electrification opportunities for the U.S. automotive market. This is the challenge that became apparent. We had invested in the time I was there a little over 5 years, over 1.2 billion in development, 250 million in actual assets to produce the equivalent engines for about 60,000 cars. And we had a lot of people looking to partake in these, they saw that the future is there, but they didn't understand how they could have access to it. And companies like this just couldn't afford to work with small deals. They needed the $100 million or billion-dollar deals. So that created the understanding of how are we ever going to grow acceptance of advanced energy technology that could be economically sustainable. And that's what created Volta. In 2014, we formed Volta Power Systems, and we started designing and developing solutions using automotive-based products specifically designed to be flexible to meet these markets. And you can see our growth here. Now, we're in all 3 of those markets we defined, starting from the premium buses, entertainers and star buses, to yachts and applications, and even transit. You can see here the The semi truck is actually a reefer unit that transports food products throughout California. We've been growing at an exceptional rate. So since we started, we've been growing to 2x year over year since 2016. So the growth has been very exciting, very challenging to manage a growth of a company that quickly. And it's just a sense of all the customers we're adding, and we continue to bring on customers year over year. And we expect the growth can continue again next year. So in summary, where's Volta at? It's number one, we provide a way to eliminate those barriers of investment requirements for these specialized markets. That tens of millions or hundreds of millions of dollars in investment that only major automotive OEMs can afford, that hurdle has been removed for what we offer. Out of the gate, our systems often, you'll see a 70% reduction or more on existing engine runtimes. So that's a combination of emissions and providing longer life to the assets. Our systems don't require any special infrastructure, and many of them our customers never plug in because we actually can charge so quickly off the existing engines so efficiently, they never plug into the grid, though it's optional. And then finally, economical sustainability. We're seeing paybacks on almost all of our applications between 1 and 2 years. So what are we asking for? What does Volta need? We're working hard to build relationships and to offer the opportunity to explain the difference in the value proposition that a hybridized electrified solution does over a full electric version. Right now, the push and the incentives are heavily focused around the goal of getting to a full electric drivetrain solution. But in all these examples we just showed here, going to an electric drivetrain really isn't where the value add is, and it wouldn't provide a good return for any of the clients that have to go that way, because it's what happens after you get to the destination is what is needed. And oftentimes that needs just the amount of energy to do whatever activity you're going to do at destination as it took to drive there. So we're looking for ways that we can encourage corporations and municipalities to take advantage of getting over 70% of the emission reductions that you can get right now today without having to invest in the infrastructure costs by recognizing that hybridized work solutions make sense over the traditional EV solution, which is going to keep coming. And this will allow you to take that transition from where we are today in technology, continue to get people comfortable in adapting and having confidence and reliability in advanced energy technology. And then when the EV solutions are economically sustainable, it'll be a much easier transition. So again, thank you for taking the time to hear our story and our growth. Again, my name is Jack Johnson. We're based out of Holland, Michigan. And if you have any questions for us, feel free to reach out via email, or you can connect through Braid Theory. So thank you very much.
Thanks, Jack.
I would like to add, I got a chance before we were all in shutdown mode to actually tour the factory in Michigan, and it's phenomenal. The growth of this company, not just on the sales side, but moving from those early stage prototypes to a full sophisticated production line to support this scale of applications and opportunity. So it's just been phenomenal to see the successes and this company, how they are ready to take on any of these market opportunities.
Thanks, Anne. Jack, I have a question for you. There are a couple of questions that have come in, but this one kind of got me peaked at that 70% number of emissions reduction. What is the carbon equivalent of that? Is that something you've measured, or is there if for those people who are looking at, either carbon credits or they're looking at swaps or something like that in a system, what would be that equivalent so they can use that in their own calculation of the value proposition?
And that's exactly what, Jim, this is a great question. So this is what we're challenged with. The way the current CARB groups and a lot of the regulatory groups look at saying, hey, I want to get that reduction, they have these they're basically look at it has to be a full EV to be able to even utilize those reductions.
Yeah.
And so what we're trying to do is, if you look at it basically, all of the, especially work trucks, when they go on scene, let's say a fire truck, let's utilize a police car. Just think of any of these applications. They go and they set somewhere, the engine's idling all day long. So you're consuming fuel at some of the most inefficient points of a vehicle's operation, because the vehicle's designed to run through a significant amount of work, right? Running on the highway is a lot different than setting at low RPM.
Mm-hmm.
So when vehicles are working, it's either turned at high idle means they accelerate the engine to be able to run tools and do the things they do. You're sitting there for 6, 7, 8 hours a day running that engine nonstop. What our products offer is we turn the engines off and do the same work. The engines never turn on all day. So you completely eliminate the emissions. So you can take an example. Let's use a Ford F-550 work truck. Mm-hmm. Those emission details are available. You can see what the emission credits would be from an EPA testing.
Yeah.
And our solution is simple. It doesn't run. You turn it off for the entire day.
Yeah.
The challenge is getting credit. This current system does not recognize this incremental capability that provides a viable economic solution for adoption. It doesn't recognize that as a value add.
Right. Thanks for that. That kind of set my. I saw the 70% number, and I wanted to see what that percentage represented. So that's actually a really good answer, because I think that going back to those companies and asking them, well, what are your specific needs from an engine idling point of view? Then I think that answers the question for them, right? That essentially it would reduce it to zero emissions over that time that car is idling, or that vehicle is idling. Thanks,
Exactly.
Jack. So what do you perceive of the roadblocks from customers' minds when you're selling them on the idea of the value proposition? I mean, do they have any barriers? Do they have any blockages?
There's two big barriers. So back 2008, 9, and 10, there was a very big push, a lot of excitement around advanced energy. And they bought in, and a lot of companies hurried up and said, we got to be a part of this investment. But as you can see, Johnson Controls, which at the time was the largest battery company in the world, they spent $1 billion and they didn't even scratch the surface. When you look at Samsung or Panasonic, they're in the $30 to $40 billion investment now each. And these companies tried to go after green energy on a very low budget and put product in the field that didn't work. Yeah. So there's a significant amount of assets that were purchased for fleets whose fleet managers' expectations, they've got to have very high uptime. Their customers expect instant response, and the vehicles are down because of this technology they can't work on, they can't get access to, nor they can get parts for, had damaged the market. So there's a significant amount of resistance to adapt technology that doesn't come with a very good pedigree with proven capability. So that's the first one. The second challenge that they have is just getting through cost hurdles. So when you look at cost, you're still adding significant cost to the value of a vehicle. So in this case, we are 75% less than if it was an EV. But when you talk about a work platform, you're still adding maybe 15% to the price of the vehicle, 20% of the vehicle.
Yeah.
And so they have to justify on a budget X amount of fleet vehicles they need to do the work. How do they make that happen? And that's where the challenge for us is, if we can get it recognized that a hybridization solution for these markets have better economic viability and can do incentivization to help them get the credit of that 70% reduction. We would see that that hurdle or that resistance would continue to be reduced.
Is some of that resistance too about whether they, I guess, believe, you know, the perception that as they, even though they might have a budget, that budget slowly gets less and less as a result of the cost savings that are involved in the lack of idling and.
Yeah, can you prove this payback? So,
yeah, right.
And that's you know, we've had product now in the field for 4 years solid with Oklahoma Gas and Electric and a smattering of others throughout the U.S. But we've seen the adoption. This is very interesting. The adoption has been in the central Midwest, and what's been driving their purchase is it's silent. And so what happens is they have these very expensive work crews, and traditionally they couldn't work on second shifts because they would bother the clients.
Yeah.
So they've been able to make paybacks on the fact that they just have to buy one less vehicle because this vehicle now can work on multiple shifts.
Right.
And they took the savings. They don't even care about the emissions reductions.
Yeah.
And that's been very unique. And we're trying to work and get it to move west, where we know that the reductions in emissions matter. You know, how can they do that economically? It doesn't matter. And we're looking to get that story correctly positioned on the west side of the country.
Terrific. What's the life cycle of a lithium ion or an NMC type technology and any kind of post-consumption environmental impact at any scale? What's the overall life cycle of that?
So for when we call it, we say automotive based, and we focus on that. Our products were designed around a Ford life cycle spec. Basically, you have to show that you can match a 10-year life expectancy, so greater than the standard life expectancy of a car. So I think the current life expectancy is 8 years. Our products have been tested to 10 years. It's a cycle every day for 10 years, full cycle, full depth of discharge. 2,000 plus cycles and over that 10-year time frame, and still be 80% or more capacity from what you purchase at. So the same, you want to give the same life expectation as that engine over 10 years. Yes, the engine wears out over 10 years, but the product still works. And so that life data, it comes from, again, originally designed for drivetrains. Our partners are actually based out of Hayward, California, that developed the core chemistry. Very similar to the same technology used in the Zero motorcycles. And so we've been very successful showing the life, and we have lots of data to support it, 20 million road miles now on the life. Now for recyclability, there's net worth. It's very valuable materials. It's nickel, it's aluminum, it's copper. There are recyclables. Building the product is very energy intensive, and breaking it down right now is still relative energy intensive. But with the scale coming, you know, the biggest shift in the automotive industry since Henry Ford has happened over the last couple of years, where large format lithium ion investments globally is off the charts. And you're seeing that scale coming in on recyclability. So our current system is we already know we want them back after end of life if we can get them. Because the market's already starting to be created as the first generations are starting to come out to the recycling world.
One last question, and then I'll turn it back over to Anne. And a shift away from automotive to the super yacht market. How do you tackle that market? What are the challenges? You know, who are the major engine OEMs? What's the future, Jack? Tell us about that future in the maritime and marine industry.
Well, very similar to the work truck industry. They came in very excited to start introducing advanced technology about 10 years ago, and there was some extremely visible, unfortunate incidences that happened with lithium ion. So there was a lot of excitement, and then there's a lot of concern, and now it's starting to get mainline acceptance again. And we're focusing on a lot of the medium size vessels. So we're working on vessels between 30 feet to 100 feet in length. And really the focus there is, it's all about day boating. Or, you know, you're going to take this vessel, you're going to go out and enjoy a day or an evening. You don't need to run that generation. Go out where you want to enjoy the day, shut it all off. You have all the power to run that vessel all day long. And that's all the entertainment, air conditioning, all accessory loads you need. That's what we're focusing on right now. The really big items, yeah, we've not done anything over 100 kilowatt hours yet. We really like to stay in that segment, as it's just more manageable, because we do stay in a low voltage state. Everything we do is 60 volts and down. So we can do the equivalent of 40 horsepower on our standard builds. Definitely can build something bigger, but as you go bigger, you need more and more power, it's going to force you to go into the high voltage applications. And that creates a significant post-sell cost or risk. You know, when you have to train people to work with high voltage, the liability risks that come with it, then you think about it even on water, it's even more challenging. You're not going to find people that can access or work on these right now, and not for quite some time. And so I don't see it being adapted into a really big vessel, you know, sport vessels for some time yet, because of the limitations of infrastructure that's there to tackle today's market.
All right. Thanks, Jack.